Hello everyone. Welcome to day 14 of our Teamcenter interview preparation series. In the previous session, we discussed workflows in Teamcenter. We saw how an item revision moves through review, approval, and release. So now we know how data flows through a workflow. But one question, before an engineer even starts designing, how does a company ensure that a similar part does not exist already in the system? Why should someone design a new bolt if the same bolt was already designed, validated, and approved before? That is where classification in Teamcenter comes into the picture. So, today we are going to cover what is classification, classification hierarchy, abstract versus storage class, attributes, key LOVs, ICO, indexing in classification, search and reuse, and real time example. So, let's get started. Let's take an example. A large manufacturing company has thousands of parts, bolts, brackets, and connectors. Every time a new product is designed, engineers create new parts, even when the same bolt, same bracket was already designed and approved before. This creates duplicate parts in the system, wasted effort, and increased cost. That is exactly the problem classification solves. So, what is classification in Teamcenter? Classification is used to organize parts and components into a hierarchical digital library so that engineers can search, find, and reuse existing parts instead of creating new ones every time. And there are three key things classification provides: a digital part library where all parts are organized in one place, the ability to find parts by searching attributes like size, material, and type, and the ability to reuse validated and approved parts. No duplicate design work. Now, let's understand how classification is organized. The classification hierarchy is like a tree structure, organized from top to bottom into three levels: group, abstract class, and storage class. Let me explain each one. Group. This is the top level organizer in the hierarchy. It contains related classes below it. For example, mechanical parts is a group. Groups do not have attributes. They are only used for organizing and navigation. Abstract class. Abstract class sits below the group. It is an intermediate level. It defines shared attributes, but it cannot store ICOs directly. For example, fastness is an abstract class. Under fastness, we have child classes like bolts, screws, nuts. The fastness abstract class defines common attributes that all child classes inherit. Storage class. It is the lowest level in the hierarchy. This is where actual parts are stored. For example, bolts is a storage class. Actual bolt parts, called ICOs, are stored inside the storage class, and storage class inherits all attributes defined in the abstract class above it. So, remember: group, abstract class, and storage class. Only storage classes can hold ICOs. Now let's see the difference between abstract class and storage class. An abstract class cannot store ICOs directly. It is used to define shared attributes that all child classes will inherit. It acts as a parent or grouping class. For example, fastness is an abstract class. Bolts, screws, nuts all sit below it as child storage classes. Think of it like an interface in programming. It defines the structure, but you cannot create instances from it directly. A storage class can store ICOs directly. It inherits attributes from the abstract class. Engineers classify actual parts in storage classes. It has a database table to store ICO values. Each row is one ICO, each column is one attribute. For example, bolts is a storage class. Actual bolt ICOs are stored here. Think of it like a concrete class. Actual instances are created here. An abstract class defines the structure but cannot store ICOs. But storage class stores actual ICOs, inherits attributes from abstract class. Now let's understand two closely related concepts, attributes and key LOVs. Let me start with attributes. Attributes are the properties that describe a part inside a classification class. They are defined at the class level and inherited by all child storage classes. Let me take the bolt class as an example. Attributes like material, diameter, length, and grade. These attributes describe every bolt stored in the library. Now let's see what is KeyLOV. KeyLOV stands for Key List of Values. KeyLOV provides a predefined list of allowed values for an attribute. Instead of typing freely, users select from a controlled dropdown. For example, for the material attribute, the key LOV might have steel, aluminum, and copper. The user picks from this list. They cannot type anything in random. Now let's see how does key LOV work internally. Each entry in a key LOV has two parts. A key, which is a short code stored in the database, for example 01, and a value, which is the display text shown to the user, for example steel. Let's see why is key LOV important. Without key LOV, different engineers might type different values for the same material. That makes search unreliable. That makes search unreliable. With key LOV, everyone selects from the same list. The data is clean and consistent, and that makes search and reuse much more reliable. Now let's understand the term ICO. ICO stands for in-class object. When you classify a workspace object like an item revision inside the classification hierarchy, an ICO is created. This ICO is the classified instance of that item revision. It is stored inside a storage class and it holds the attribute values for that specific part. Let me walk you through an example. An engineer has created an item revision for a bolt M830 in Teamcenter. Now they classify it inside the bolt storage class in the classification hierarchy. When they do this, an ICO is created. This ICO stores material as steel, diameter as 8 mm, length as 30 mm. And this ICO is linked back to the original item revision using a relationship called TC classification. So the flow will be like this: item revision, ICO created, stored in storage class, and linked via TC classification. There are three main things to remember about ICO. Each workspace object gets one ICO when it is classified. The ICO stores the actual attribute values for that part. The last one is ICOs can only be created in storage classes, not in abstract classes or groups. Now let's talk about indexing in classification. Think about this. If a company has 50,000 classified parts in the library, how does the system quickly find all steel bolts of 8 mm diameter? If the system has to scan every single part record, it will be very slow. That is where indexing helps. So, what is indexing in classification? Indexing means marking specific attributes as searchable so that the system can quickly retrieve matching paths from a large library without scanning every record. Let me explain how it works step by step. Step 1. The admin opens the classification admin application in Teamcenter and marks specific attributes as indexed. For example, material, diameter, length are marked as indexed. Step 2. Teamcenter builds an index table for those attributes in the database. Step 3. When an engineer searches by that attribute, the system queries the index directly instead of doing a full table scan. Step 4. The result is a much faster search response. This is especially important when the classification library has thousands or millions of parts. Now, two important points about indexing. One is not all attributes need to be indexed. Only the attributes that are frequently used in search should be indexed because indexing takes storage space in the database. Another one is the admin decides which attributes to index based on how engineers typically search. In short, indexed attributes provide faster search, non indexed attributes still searchable but slower for large datasets. Now let's bring everything together. This is the main purpose of classification, search and reuse. Let me walk you through the complete search flow step by step. Step 1. The engineer opens the classification module in Teamcenter. Step 2. They navigate the hierarchy, mechanical parts, fasteners, bolts. Step 3. They enter attribute values. Material, steel, diameter 8 mm, length 30 mm. Step 4. The system queries the indexed attributes and returns all matching parts from the library. Step 5. The engineer selects the existing part and reuses it directly in the new design. Here, no new part is created, no duplicates, no wasted effort. And the benefits of this are very significant. Classification can reduce design time by up to 80%. It eliminates duplicate parts in the system, ensures reuse of validated and approved parts. It reduces inventory and sourcing cost. Now, let's look at where classification is actually used in real Teamcenter projects. Standard Parts Library. Companies classify all standard parts, bolts, connectors, pipes into a library in classification. Engineers reuse these directly in new product designs. No one designs the same bolt twice. Part search before design. Before starting any new design, engineers search classification first to check if a similar part already exists. This is a standard practice to avoid duplicate items in the system. Data migration projects. During a Teamcenter implementation, classification is used to organize all migrated parts into a structured hierarchy. So, all historical parts are properly classified before go live. Supplier and component management. Approved vendor parts and supplier components are stored in classification with full attribute data. So engineers can select validated parts during design without extra coordination. So to conclude, classification in Teamcenter organizes parts into a digital library for search and reuse. The hierarchy is group, abstract class, storage class from top to bottom. Abstract class cannot store ICOs. It defines shared attributes for child storage classes. Storage class stores actual ICOs and inherits attributes from the abstract class. Attributes describe a part. KeyLOV provides controlled drop-down values for those attributes. ICO stands for in-class object. It is the classified instance linked to item revision via the TC classification relationship. Indexing marks specific attributes as searchable, enabling fast search in large libraries. And the whole purpose is to search by attribute values, finding existing parts and reuse them. That's all for today. Thanks for watching.